Let's jump straight into it, guys. Today's explainer is a full-on mission briefing for a seriously high-stakes role at ISGEC Heavy Engineering Limited. If you're already operating in the EPC space or working with process plans and heavy manufacturing, you know the deal. The literal lifeblood of these multi-million-dollar facilities flows right through their piping and valve systems. We're going to break down absolutely everything you need to know about this open position for a piping material and valve engineer. This is the kind of job where precision isn't just a nice-to-have, it's non-negotiable. So let's unpack exactly what ISGEC is looking for, your day-to-day battlefield, and of course, the financial rewards.
Right out of the gate, we need to talk about the number 8 to 12. This is absolutely crucial. This isn't some entry-level gig where you're just learning the ropes, right? That 8 to 12 represents the elite years of heavy-duty piping engineering experience you need under your belt to even be considered. They're hunting for seasoned veterans. If you spent the last decade practically breathing industrial piping systems and mastering the complex dance of material flow and pressure, this is absolutely a target you should lock onto.
But, all that field experience needs a rock-solid academic foundation. To match their ideal candidate profile, you've got to have a BE or B.Tech specifically in mechanical engineering. That baseline mechanical know-how is your ticket in, because you're going to be running complex structural and fluid dynamic calculations day in and day out. So if you've got that degree and you've cut your teeth in harsh environments like oil and gas, power plants, or boiler operations, you are exactly the kind of engineer they're looking for.
Okay, moving on to Section 1, the mission, your core responsibilities.
As a piping material and valve engineer here, you're definitely not just staring at isolated pipe layouts. You're going to be designing and engineering massive, comprehensive systems. We're talking specifically about skids, incredibly complex modular constructs, and process waste heat boilers, or PWHBs. These things are colossal. Your engineering work is the literal linchpin that ensures these massive modules operate flawlessly and safely, handling some of the most extreme industrial processes imaginable without breaking a sweat. Now, your day-to-day workflow follows a very strict logical path. Step 1, you start by deeply analyzing the P&IDs. Those piping and instrumentation diagrams are your absolute baseline. Step 2, from those diagrams, you're selecting the exact materials and valves required. Step 3, you translate all of that into a comprehensive bill of materials, your BOM, for the whole shebang. Finally, Step 4, you execute rigorous vendor document reviews to make absolutely sure that what's actually being supplied perfectly matches your exact specs.
And right alongside that workflow, you'll be constantly creating and managing two highly critical technical documents. On one hand, you've got the PMS, the piping material specification. On the other, the VMS, the valve material specification. Think of these as your engineering Bibles for any given project. They dictate exactly what goes into the facility. And remember, you aren't just blindly following these specs. You're the one building and owning them from the ground up.
So the takeaway here is that your material and valve selections are far from random, and they sure aren't based on what's cheapest in the catalog. They have to strictly account for some truly intense process requirements. We're talking extreme pressure thresholds, wildly fluctuating temperatures, and severe corrosion conditions. If you pick the wrong material for a highly corrosive environment, a multi-million-dollar module goes down. Your deep expertise in how specific alloys and valve designs reacts to these brutal elements is exactly what ISGC is paying you for.
Let's shift gears to Section 2, vendor management and specialty engineering.
In this role, you're going to dive incredibly deep into manual valve engineering. That means it's on you to prepare detailed material requisitions, the MRs, and highly precise valve datasheets. You'll then take these documents and basically use them as your ruler to ruthlessly evaluate technical proposals from vendors. When a vendor promises their valve can handle a specific pressure spike, it's your job to tear into their technical drawings and datasheets to prove they aren't just bluffing.
And all of that builds directly into the truly specialized elements of this job. I mean, standard pipes and valves are one thing, but you're also going to be handling the engineering for piping specialty items. We're talking about complex components like expansion bellows that absorb thermal expansion in the system, industrial strainers, and other highly specialized parts. Honestly, these are often the most delicate and critical pieces of a system's entire flow dynamic.
But to pull all this off, you absolutely cannot work in a silo. You are the central communication hub. You'll be working completely cross-functionally, bridging the gap between external clients, the vendor supplying the parts, your internal procurement teams, and the multidisciplinary design engineers mapping out the rest of the plant. Essentially, you are the crucial translator, turning complex engineering reality into actual procurement action.
Next up, Section 3, the arsenal.
Essential tech stack and standards. Look, in today's heavy engineering world, a slide rule and some graph paper just aren't going to cut it anymore. You need to be highly proficient in modern enterprise tools. You've got to be super comfortable navigating SAP for material management, and obviously, you need strong Microsoft Office skills for all those data sheets we just talked about. But crucially, you really need solid experience with Navisworks and 3D model review tools. You have to be able to visually interrogate a digital twin of the piping system way before a single piece of steel is ever cut. And you're playing by a very strict rulebook here. Every single design and material choice has to comply with an absolute alphabet soup of heavy engineering codes. You need deep familiarity with ASME and API for international mechanical and piping codes, plus ASTM and ANSI for your material standards. And since ISGEC handles massive boiler projects, you absolutely must know IBR, the Indian boiler regulations, inside and out. Compliance here isn't just a friendly suggestion, it is a strict matter of legal and operational safety.
Finally, let's look at Section 4, the reward and next steps.
So, for a pro bringing that highly sought-after 8 to 12 years of specialized experience to the table, ISGEC is putting up a very competitive package. We're looking at an estimated cost to company ranging from 12 to 22 lakhs per annum. To break that down into practical terms, depending on your tax structure and the exact benefits package, you're looking at a typical monthly in-hand salary of roughly 75,000 to 1.35 lakh rupees. And as for the home base, you'll be bringing your engineering talents to their massive operational hub located in Noida, Uttar Pradesh. All right, so what's the next step? If you've got the expertise we just went through, the BTech, the decade of grit, the total mastery of P&IDs, and those sharp vendor management skills, you need to jump on this. Go ahead and fire off your updated resume directly to prakash.chandra@isgec.com. Or if you want to dig a bit deeper into the massive projects they're building, go check out their website at isgec.com. We've covered the intricate material specs, the heavy-duty software stack, and the incredibly strict safety codes required to pull this off. The only real question left is this. Are you ready to take on this level of immense responsibility and literally engineer the future of heavy industry? If you are that highly focused, seasoned pro, ISGEC is waiting to hear from you. Thanks for tuning into this explainer, and keep building the future.